What's up, guys? Welcome to part 4 of this video series, and in the last video we got to this part here and we basically stopped. Now it's been kind of slow up to this point, but right now we're about to dive into something that I find quite interesting, and that is the Python input method, which is built in so you don't have to do anything. But so we're just gonna erase all this. We're going to start from scratch. And the input method is this, and it takes it takes parameters of what you want to output to the screen. So if I wanted to say, "Hey customer, enter your name," and then this would actually have to be, if I ran this, it would say, "Hey customer, enter your name" in the console, and I could enter Steve, something. But now, what happens to Steve? Steve is entered by the user, but now we need to access his name or store it. So what we do is just simply say, name can be equal to input, "Hey customer, enter your name." And if we run this again, we'll see the same result, Steve. And now we have name. So if we print name, you'll see that Steve is actually stored into our memory. We can actually access it now. Run it, Steve, and then it prints out Steve. So this is useful to basically collect information from the user when your program is running off of user-based entries, and basically when the user enters something, then you're going to do like, if the user enters this, then we'll get into that more detailed later. Right now we can just create a simple program that says, hey, name equals input, hey customer, enter your name, and then we'll say if name is equal, actually I don't know if I want to do if right now. We might save the if statement for later. Right now let's just try something simpler than that. So we have name, which is set to the name, and then we could say the age is equal to input, now enter your age. I'll do the if statement is actually pretty is a pretty cool conditional. It basically just takes a conditional. It's a conditional statement that takes something and anyways, we'll get into it. I think next video will be a good place to start for that. So right now we have the name and we have the age, and let's just get, I don't know, color. Input. What is your favorite color? Alright, so let's run this. Enter your name. Let's say Steve. Actually, I'll put my real name. You guys should know my real name, I guess. I'm not 15 though. What is your favorite color? There. Alright, so now we have all this information, and we could come down here and we could say print name. We'll take away this space and we'll say name. Print age is set to age, and we'll print color. Let me do this last one like this, color. So now we can print out all of our variables after we get them. So Steve 55. Steve 55 blue. So now let's say that for let's go ahead and comment this stuff out. So now we're just working with these 2 lines of code right now. Let's say that for the input, we say, hey customer, what's your name? And they put 55. Now, name is equal to 55, but we don't want it to be. We want name to actually be, okay, I don't know what I just did, but clear that. And we want name to actually be a string. And if they don't enter a string, then we don't want what they're putting out. We don't want it. So what we could do is cast this entire statement to a string. And we could say, hey, this has to be a string, and if it's not, then it's going to spit out an error. So let's enter the string Steve, and we get it working perfectly. Now if we run it again, and we enter 55, you know what, 55 could also be stored as a string too. So this kind of isn't a good example, but let's say we did it for age to where integer, we want the age has to be an integer and it cannot be a string. So if we, let's pretend that this line says enter your age, and we hit, and we say Steve instead of age. What it's going to do is it's going to spit out an error saying that invalid literal for int. The integer or the numeric literal cannot be a string because we said it has to be an integer. So let's set this up the right way. And let's say so for this we'll say this input has to be an integer and it's not going to contain decimals, so it's not going to be a float, and this is going to be just a string. So now if we run it, it's going to give us Steve 5 and Steve 55 pink. So if we did enter a excuse me, if we did enter a character for this, or I mean a string, it would actually present an error. So that's another way to make sure that you do get what you want from the user. And let me think. Now, as far as forming algebraic expressions through these variables, it's super simple. It's not even, it shouldn't even throw you off. But say we take this variable age and we want to add 10 to it, and we want to scare the user saying, hey, you're not actually 55, you're really 65. So if we, what this operation does, it says, hey, let's take the age that we get from the user and let's just add 10 to it. And then we'll print that out as for the age. So int age plus 10. Okay, so Steve, and I think I'm 30 years old, and I think my favorite color is blue. But it says, wait, no, your age is actually 40 because I added 10 to it. So that's simple algebraic expressions. You could also do division, and just save some time here. And these hash, whatever they're called, these number signs are ways to comment out lines. If you wanted to add comments, then you do that by adding these hash. Say this is a cool program. And so now if we run age divided by 10, we'll do 55, and we'll get 5.5. Now the reason why we get 5.5, we could actually convert this into, if we say integer age divided by 10, and that's actually going to give us an integer value of age divided by 10. So let's try that again, and if we do 55 down here, it's going to take off, it's basically just going to cut off the decimal. Anything from 0.5, where it said 0.5, from the decimal on, it's just going to cut it off. And so that's can be useful, but basically it's a float